In this video, we are going to practice drawing a force diagram for an object that is moving in a circular path. We are going to learn how to calculate the value of the centripetal force or the net inward force acting on the cart. And we're going to learn how to identify what force or forces are causing that centripetal or inward force. And finally, we'll do a simple calculation applying that formula. You'll notice that the way that we approach this problem is much like the problems that we approached in the balanced force model and the unbalanced force model. The difference is that the net force, instead of just saying it's equal to ma, we're going to say that it's equal to mv squared over r. So last week, when you did a lab involving measurements of centripetal force for an object that moves in a circle, we found that centripetal force was equal to m times speed squared over radius. When we read this problem, we're going to start by drawing a force diagram for this cart, just like we've been doing the last two models. So we've got a 2 kilogram cart, and it's moving in a circular path. So if we've got a cart, and it's moving in a circle, just like we're used to saying, there's going to be a force normal up that the path applies to the cart. And there's going to be the force of gravity of the entire Earth pulling down on the cart. And there will also be one other force. If you imagine something going in a circle, a car, say, driving around a roundabout, it may not be obvious what force is pushing inward on the car, keeping it going around the circle, until you think about what happens when the car doesn't drive in a circle anymore. If the roads are icy, like they have been recently, and you're trying to drive a car around the circle, it gets much harder. That helps us know that force of friction is the force that's unbalanced, and it's always directed towards the center of the circle. So the force of friction that the path applies to the cart, that would be our centripetal force. So if I said, what is the force or forces that cause the centripetal force in this problem, it would be force of friction. If it helps you to kind of picture, you might just want to draw like an outline of a circle. If we were drawing a force diagram when the cart was over here instead, the force of friction would be pointing the opposite direction. You just need to understand it's always pointed towards the center of the circle. Then, so to answer part A, what force causes this cart to move in a circular path? The centripetal force in this problem is the force of friction. Next, it says calculate the value of the centripetal force. This would be very much like saying last chapter, calculate the value of the net force. If we were to write a net force equation for the x-axis for this cart, it would be force of friction equals mv squared over r. So to calculate the value of the force of friction, which is the centripetal force, because there's only one force in the x direction, we would take the mass of the cart, which is 2, and we would multiply it by the velocity of the cart, which is 6 squared. We divide that by the radius of the circle, which is 4, and we just calculate a value for that force of friction. So in this case, the centripetal force and the value of the force of friction is 18 newtons, and it's always directed in towards the center of the circle. So that answers part B, calculate the value of that centripetal force, 18 newtons. Finally, moving on to part C, C says calculate the coefficient of friction between the cart and the path. This is pulling in something that we knew from last chapter, which is that the coefficient of friction relates the normal force and the force of friction. So we figured out the force of friction is 18 newtons. We're trying to figure out the coefficient of friction. To figure out the normal force, first we've got to remind ourselves that to relate force of friction, it has to be the same two surfaces. So force of friction is the force that the path is applying on the cart in the horizontal direction. So over here, the force normal that we want to know about is the path pushing up on the cart. Those two forces are related because it's the same two objects interacting, and they're at 90 degrees to one another. We can figure out the value of the normal force by figuring out the weight. So off to the side, that's what I'm going to do. Weight equals mass times 9.8. The weight is 2 kilograms times 9.8, which is 19.6 newtons. And since forces are balanced in the y direction, normal force is also 19.6 newtons. So I'm going to use that, take that right over here to the normal force. The normal force is 19.6 newtons. So mu, the coefficient of friction, is 18 divided by 19.6, which is 0.92. And the coefficient of friction is unitless, so you don't need to worry about any units, but it basically says that the force of friction for this cart is 92% of the value of the normal force. So we have successfully answered all 3 questions. Now it's your chance to try. You're going to be practicing drawing force diagrams for objects that are moving in a circular path, identifying the force or forces that cause that object to continue moving in a circular path, and doing a few simple calculations with the centripetal force equation, mv squared over r.